Good morning, everyone.
Good morning. I would like to welcome everyone to day 3 of SAB Radionuclide Cancer Risk Coefficient Review Meeting. Before we start, I would like to do the roll call. I will start with the panel members in the room. Dr. Yiling Shu,
Present.
Dr. Meyer Attendilashvili,
Present.
Dr. Roland Banky,
Present.
Dr. Harry Coolings,
Present.
Dr. Mark Little,
Present.
Dr. Chinhua Mao,
Present.
Dr. Bruce Napier,
Present.
Dr. Ruth Fiber, she is absent today.
Online.
Dr.
She'll be
Daniel
online in
Tran,
an hour or so.
excuse me?
Should be late online.
Okay. Dr. Daniel Stram,
Present.
Dr. Daniel Strong,
Present.
Dr. Wei Shun Wang,
Present.
Dr. Gail Woloschuk,
Present.
Dr. Lydia Sabraska.
Present.
Thank you. Now, for those who attend remotely, Dr. Eric Grant,
Present.
thank you. Dr. Steve Simon,
Present.
good. Very good. Now, I would like to turn the meeting over to our panel chair, Dr. Yiling Shu.
Good morning, everyone. Welcome back. I hope we still have enough gas in the tank to finish the last half day. So I guess I'll turn to EPA first to see if there's any follow-on comments from yesterday. Thank you.
Good morning. And thank you, Dr. Zhu. Since I may not get another opportunity, I want to again thank the entire panel for really thoughtful discussions this past 2 days and comments. We really appreciate them. We've been taking notes, a lot of notes, and we look forward to getting your recommendations. So thank you so much. I also want to acknowledge our colleague on Pacific time, David Powell, who has been getting up 6 a.m. for this, and we thought this was enough cruel and unusual punishment for him, so we let him off the hook this morning. But I heard he's online again, so thank you, David. Regarding yesterday's discussion, I think particularly it was questions 3B and 4A. We really appreciate and we essentially agree with many of the comments and observations that you made. We do need to be more careful in our use of terminology and clean up the document in a way, in a sense. We had noticed that some of our terminology, for example, the use of incidence and morbidity, and that's why what really wanted to ask you because of what your thoughts were on that, and really appreciate that. But some of the other things that you pointed.
It's just going completely sideways. Out here, it's just going completely sideways.
Oh, could we tell who? Yeah, can you please mute?
Please mute yourself.
And some of the other things that you pointed out, for example, when we average something, I think Dr. Simon made that point on the first day that it wasn't clear what it is that we're actually averaging. And Dr. Straub mentioned that when it's not clear when we mean mean, we're using arithmetic mean or median. So we need to watch out for that. There was a comment about use of risk or rate that we were kind of loose with that term. So all of that cleaning up. And then, of course, error and the use of the term error and uncertainty. That we need to at least define in the glossary. If we don't necessarily conform to the terminology in the metrology arena, at least we need to be very clear of what we mean by those terms. So those are all well taken, and we would definitely do that. One thing that we were talking about making measurements in metrology and making measurements. And it occurred to me as I was thinking about it that, we don't really in this exercise, we're not making any kind of measurement. And then I remember the late Dr. Tui about internal dosimetry, that he said, internal dosimetry is just an art based on science. Because somebody may show up and they've had this traceable amount of radionuclide that they've inhaled. You know exactly how much they inhaled, you know exactly when, what time, what day, what is their dose. And we can't measure that dose. So it's and that right then, it starts all the talks about the uncertainty and so forth. So it is a different, and then we're talking about risk from that and all the other parameters that the other thing that we noted in the discussions and the comments that Dr. Powell made is that we realize now that there's a good bit of information in the Blue Book that really needs to come, and we need to expand on that in FGR 16 and kind of make it, don't assume that someone who's reading FGR 16 knows all those discussions in Blue Book. Bring some of that in here and if appropriate, expand on them and also clean it up. I think many of you noted that there are parts of that are in this section and that section and this section, they need to be put together and some of them need to come earlier. So we that was very good, and we're definitely going to do that. The big question about the uncertainty, and of course the risk estimates that we have are a central estimate of risk. And the way that's calculated is a bunch of numbers. We have from the biokinetic models, the risk model, the dose values, those are all single values, and there are really no uncertainty in any of them. Because when we take say we take an adult female phantom, there is no uncertainty in that at all. That's pretty much set. There's no uncertainty in the size of the organs. There's no uncertainty in the amount of fat that we use in that calculation. Those are all precise values that we use. And but the same thing with biokinetic model, the absorption fractions and so forth. Those are single values and that we use to do the calculations. And I think what they try to do in those categories of the A through E that was done, it was, and I think Dr. Collins really described well the purpose of that. It's and to me, it's something the David, Dr. Leggett, and so forth. They were trying to communicate to their own counterparts, whoever that is modeling, to how much confidence they have in their model. For example, the parameters that use in the biokinetic modeling, or whether a radionuclide, the data from biokinetic of a radionuclide came from a healthy human subject. Did it come from an unhealthy human subject? Did it come from an animal? Or none at all. It was just it was biochemically analog to something else that we had data for. So that contributed to how good we feel about using these values. Or for external exposure, for example, if it's something that has a hard gamma emitting, we can have more confidence in modeling that than something that emits very low energy soft brimstone radiation that all comes. So that's so you would see that in the examples that are given, you would have for some radionuclide that for external exposure, they give it category E, but for ingestion, they have a category A. They have a lot more confidence in doing ingestion for that, but not so much in doing external exposure. So it was, I think, in a way, a communicate to other scientists, modelers who see the gaps. These are the gaps. These are the things we don't have confidence in if we ever wanted to improve those. But for our purposes, for at least, when we talk about what do we owe, I think that's the phrase that Dr. Strom used. We owe the stakeholders. The users of this to have some value of how uncertain, what are the uncertainties with these risk coefficients. And we have a lot of interest in that because we do a lot of communication with stakeholders, and whether they're general public, whether they're decision makers, regulators, we need to be able to communicate. And everybody on this panel, I'm sure, appreciates how difficult it is to communicate and put in context some of these risk values that we calculate. I can't help but think that we have, you can take a low energy beta emitter, bury it in soil. So it's buried in soil. There is some very low energy brimstone photons coming off of it. We put somebody barefooted on that soil and we give you a risk. That's and how do you communicate that? Okay, and say, okay, is this risk obviously it's a non-zero, 10 to the minus whatever risk. You say, okay, well, is it off by a factor of 10? So it could be. Let's divide it by 10. Still non-zero. And it was whatever it was minus is minus whatever plus 1, right? How do we communicate? That's a real challenge. And I think that to make that, in some ways, we think it's really not a mathematical problem. We could make it a mathematical problem. It would be a very complex problem because all the radionuclides, the exposure path, all of that stuff, and it becomes a very complex project. And it's doable. It would be very time and effort intensive, but at the end of, does it really accomplish what we want to do? And we don't think it does. And it might even imply something that isn't there. It implies certain knowledge that we don't really have about the extent of the uncertainty. There is one thing that I wanted to, I'm sure you noticed that too, there's a discussion in section 7.10.9 of this report that brings together some of the 7.10.9. And these are some really 4 bullets that it brought in from some of the discussion in the Blue Book and the 2007 documentation. And it talks about, and I like to, there's the short bullets, I like to read them. It says risk projections for total cancers for all cancer sites, if you have uniform irradiation of the body, are likely to be within a factor of 2 or 3 of actual risk for the US population. So we take the variability out, the US population, total cancers, all cancer sites, we're likely within a factor of 2 or 3 of what that risk. And then we say for individual cancer sites, if we're talking about irradiation or exposure in adulthood, we're talking about being within a factor of 3 or 5 or actual risk. But if the exposure, but that's not for all cancer sites. For stomach, uterus, and liver, it will be a wider range of uncertainty. And if the exposure is at childhood, again, there will be larger uncertainties. And then when we're doing these calculations for the census for US population, the demographics that we have in 2014 and 16, certain number of people are at this age, certain number of people are at that age. And then, and they're irradiated at different ages, different cancer sites. Again, try to put mathematics in it is possible, but how meaningful that will be. And I think that probably the level of information, level of uncertainty we can comfortably kind of communicate. And we need to expand on this. We need to kind of say where that's come from. Why do we think that? So it needs a little more explanation, not just out there, and refer people to read somewhere else. That discussion needs to be here. But there's another bullet that's really important, and that section ends with this bullet. And it says, an important caveat is that the analysis did not fully account for uncertainties associated with the shape of the dose response of low doses and low dose rates. The LNT hypothesis was assumed to be correct. And we all know that there's uncertainty, quite a bit of uncertainty there. But we don't take that into account. So when we say that these risks that we're calculating could be a factor of 3 and 5, we're assuming no uncertainty when we're extrapolating back to very low doses. And that, but the reality, of course, if you wanted to talk to someone about, okay, how certain, how confident you are about these risk values, we haven't even taken that into account. And how do we take that into account? So I think it's very difficult to treat this subject quantitatively and mathematically. But we hope that at least we provide what we know again at this level, but expand on it a little bit more, provide more rationale. To get that, basically, hopefully be able to communicate that to our stakeholders. But right now, people that use these risk values, our Superfund program that plugs these into the preliminary remediation goal calculators, other software that use these programs, you take our central values and do them. And so they essentially meets their needs at the moment. But we agree with you that for certain users, including our own, for sake of communication to our stakeholders, we need to better communicate the uncertainty associated with that. And if you have any recommendations on how to do that, how to be able to do that, I know there's not a perfect answer, but we really appreciate that. That's it. Thank you, Dr. Zhu.
Thank you so much. Any comments? All right, thanks. Then we're going to move to the next agenda item. That's discussion of charge question 4B. Dr. Stram is the lead discussant. Dr. Simon, you have a question for?
Thank you. It's not really a question, but I want to offer a comment in response to Armin's statement. And with all due respect to Armin, I just like to offer these comments. The first thing is that the act of not assigning an uncertainty to a parameter does not in any way mean that it's uncertain. In fact, parameters and models for which they usually do not assign uncertainties is because it's usually too difficult or maybe too large or something. So oftentimes those parameters are the worst offenders, and they really don't. This might be for like a gut absorption of plutonium or something. So not assignment of an uncertainty to a parameter implies in no way that that parameter is uncertain. I just want to correct that. The second thing is there is a belief that these values are central estimates. Well, no one has shown us that quantitatively. And the only way to do that is by a numerical uncertainty analysis. Now, it may be in the Blue Book. I haven't studied that. And so, again, with all due respect to the Blue Book, and from which these 4 bullet points are drawn, maybe it's been done. But if you don't do a numerical uncertainty analysis, you really don't know that you have central estimates. You just have point estimates. Point estimates derive from multiplying a bunch of numbers that you think are good numbers together. So I want to emphasize that to not overstate what we have, and that's just as much of a hazard as anything else. In terms of communication, this panel is not set up to advise on risk communication. That is a whole field in itself. It's not been a field that's been very successful, but it is a difficult one. And I want to end this comment with stating I'm not trying to force EPA into a position of doing a numerical uncertainty analysis for all 1,300 radionuclides. I'm not pushing for that, but I want it to be realistically viewed for what it is and what it is not. Thank you.
Thank you, Dr. Sum. Very good comments. And is this related to this topic, Dr. Strong?
Dr. Charles Land of NCI once made a presentation at an NCRP meeting a decade or so ago, where he looked at, gave a uncertainty in the LNT model. And he gave a 50% probability that there was a threshold and a 50% probability that there wasn't. And he ran those calculations and presented them. I don't know if that was ever published, but it was a way of looking at the possibility of no effect at low doses. And interestingly enough, it didn't make a whole lot of difference given the 50% probability of a threshold in the analysis that he presented. And I wonder if, to please some of the people who are anti-LNT, it might be worth mentioning the possibility that at very low doses or very protracted doses, the risk is zero. Dr. Benke's kind of microdosimetry analysis indicates there's a lot of cells that aren't hit. If you look at alpha particles, you get at 1 gray, you get about 1 nucleus out of 4 is hit with alpha particles, 1 cell nucleus. This was all the microbeam experiments and stuff like that. So some of these things, when you get down to lower doses, I mean, there is uncertainty that perhaps EPA could think about acknowledging there. Anyway, that's just my opinion.
All right, keep this in mind when we write our recommendations. These are very good. All right, Dr. Stram, your podium is yours.
Yes. Good morning. Let me try to get a little closer to the mic. I'm going to read. I've got slides. I can either. Okay. Okay. Yeah, that's all right. All right. So the charge question 4.B asks, are the examples in Appendix A useful and appropriate for demonstrating the use of FGR 16 risk coefficients in a range of applications? Okay. And just to remind everyone, what is a risk coefficient or how is it used? For a selected exposure scenario, the computation of risk big R involves multiplication of the applicable risk coefficient small r by the per capita intake I, or for external the exposure X. So therefore, big R is equal to little r times I for intake by inhalation or ingestion, and big R is equal to little r times X for external exposures. So what is risk? It's not really stated here, but the risk is the increase in the lifetime risk of cancer due to either short-term exposure periods or long-term. And the analysis is based on the linear no threshold hypothesis. It's because the risk can be to a small group of people or it can be to a large group of people. The same dose spread over many people is assumed to cause the same harm that it would be spread over a short number of people, small number. So I'm going to give you example one in the
Next slide, please.
appendix. Oh, next slide, yeah. Suppose there's a short-term release of 1 times 10 to the 9th becquerel of iodine 131 as a vapor from a reactor, and that observed atmospheric conditions indicate an atmospheric dispersion factor of about 1 times 10 to the minus 6 seconds per meters cubed inverse. Seconds per meter cubed, I guess, is the right way of reading that. Compute the morbidity risk associated with inhalation as the cloud passes over the population. So that is example one. And the answer to that is given in the text. The time integrated concentration in the cloud is equal to, well, 1 times 10 to the 9th becquerels times 1 times 10 to the 6 seconds per meters inverse is equal to 10 becquerels per second per meter inverse per meter cubed.
Excuse me, could somebody send these out to us too? Because it's really small to read the numbers. Is it? Okay, thank you.
Yeah, this is straight out of the book. And then the average inhalation intake is given in table 3.2. The morbidity coefficient for inhalation of I-131 is also given in table 2.1. And the estimated morbidity risk is therefore the multiple of all of these quantities, and it comes out to 1 times 1.17 times 10 to the minus 9th. And I have reviewers' comments, and starting with my own. This is from the text that Diana sent to us just before the meeting began. A few more examples are needed, focusing on external exposure. I think at least 3 examples rather than 1 at present of external exposure should be provided. so that the three exposure scenarios for external exposure are all included. These three are external exposure from radionuclide in air, on ground surface, and contaminated soil at an infinite depth. The units of activity for calculating the exposure to external radiation seem complicated and need more explanation somewhere in the text, perhaps in the introduction. And Dr. Collins' comment was that the examples were well chosen and illustrative of situations that can be encountered in application, although they are necessarily simplified in terms of deriving the input data. And then he has a comment about example one, and actually another comment about example two, which I'll, but the bottom line is that he agrees that the examples are well chosen. And Eric Grant also agreed. Steve Simon indicated that he did not like the casual way each calculation in Appendix A is introduced and written. In addition, the units of the end product should be given and are not. While this section is not complicated, the presentation is not formal enough for my liking and very much looks like an afterthought. A better presentation to the formula and units is recommended. So, despite the various parts of the text that talk about uncertainties, there's no discussion of including uncertainties in the example calculations. This is an omission that needs to be addressed. Dr. Wang gave a following comment: the sample calculations in Appendix A are easy to follow. Cases of internal exposure pathways via inhalation and ingestion are, as well as external exposure pathways via direct radiation and submersion, are discussed. Inclusion of serial decay and secular equilibrium in the examples is a nice touch. The estimated mortality risk on line 21 of page 242 should be 1.17 times 10 to the minus ninth. I think that's actually the answer. It was unclear to me whether that was a correction to one of the examples or a number in a table. And Dr. Woloschuk stated that the examples seem adequate. A limitation of the entire work is the separation of radiation risk from chemical risk. For example, for example, there's no discussion of the hazards that come with the lead component in the radionuclide, only the radiation component. There is, of course, a hazard from the lead itself, and EPN knows this and works with these chemical risks. I wonder if some inclusion of chemical risk would be possible. This, of course, is true for many of the radionuclides discussed in this report. So that's the those are the comments of the panel. I think they're generally positive, but we do need to put together a consensus report view that will handle, I think, the comments of the reviewers. It'll take a little bit of effort to get the consensus. And I call upon others to give their opinions now, or ask additional questions.
Okay,
Let's go ahead.
yeah. I didn't have a problem with the examples as given. I think they were a little bit simplistic. Given that one of the major users of this is going to be the Superfund program. It occurred to me that perhaps a highly simplified example with more than one radionuclide and more than one pathway would be advantageous to show how to add them together. So it occurred to me that, the one that came to my mind for Superfund would be something with some contaminated groundwater, perhaps Deck 99, something that's mobile, and some contaminated soil, perhaps cesium, and maybe a farmer scenario where somebody's growing something in the soil. So you would have some contaminated food, some contaminated water, and external exposure. And I picked cesium because then you can throw in the barium for the chain decay and show how all of this comes together in a single example. I could write this in a page, but I think it would show people how the numbers fit together and how you use them in a practical example.
What about using chemical risk rather than radiation risk as an example?
For almost anything other than maybe uranium and plutonium, I'm not too concerned about it. The suggestion here of lead, I mean, there's such a tiny amount of lead in that particular example. I don't think the chemical risk is that bad, but for some of the other, I don't know if that's something that fits here or not.
Look, I don't know if it fits, but it should at least be acknowledged in the report. I don't think it would take much to do that. But the reason, I mean, I picked lead because that happened to be one of the examples that was being used. For lead, it's actually possible to discern what comes from the radionuclide, the radiation part, and what comes from the lead, because we have non-radioactive lead. And I'm sure there are scenarios that are well worked out for lead from the chemical perspective. So I think just stating that would be important. Plutonium is, of course, very, very difficult because we don't actually have non-radioactive plutonium. And plutonium, I mean, my own lab has done a lot of work with like what plutonium does. It ties up transferrin, it messes up the liver, but a lot of this stuff is not well, it's not known whether it's from the plutonium or the radionuclide or both. So that's a much more difficult situation. So I don't feel as bad about plutonium because probably we're considering both at the same time.
Good. Then either Dr. Simon or David.
Yeah, to respond to your plutonium question, there was a paper by Greg, probably Diane Liu, LUO, and Greg Claycamp, where they compared plutonium-244, which is such low specific activity that it's more chemical. And they looked at the oxidation. I'm going to get this wrong, but they compared it with iron. And the oxidative damage from iron was 7 times higher than that from plutonium-244.
I know that work. I published with plutonium-244 as well.
Okay.
Right.
With Mark Jensen, who was at Argonne for a while now in the Colorado mines.
And then the one that the only one that we in health physics consider as a chemical toxin rather than a radiological toxin is highly soluble uranium. And it's a nephrotoxin, right? And so there we know that the limiting value for occupational exposure is the chemical, is the threshold limit value from the ACGIH. So that one is well known, well documented, and uranium places that process uranium in that soluble form do have chemical protection programs. Now, when you get down to environmental levels, I don't think the chemical toxicity is a factor for uranium. But I wanted to add one clarification, if I can. I don't know if there's a camera on me that would be helpful. But I will. Is there a way to get on camera? I don't know if you can see this. But the idea of seconds per cubic meter, if you would express that, let me see if I can hold this right. I don't know how to hold it right. There we go. A second per cubic meter is actually how many becquerels per cubic meter you get when you release so many becquerels per second. Now, Bruce, is that correct?
That's true for a continuous release. For the acute one that they were doing, it would be the number of becquerel seconds per cubic meter, which is the time integrated air concentration per becquerel released. The numbers are the same, but yes.
Well, so I was addressing that question, and it would be much clearer for me. Whenever I see seconds per cubic meter, I'm going, oh, this is the goofiest thing in the world. I have no idea what they're talking about. But if you would just simply express it that way, that would help.
Dr. Simon?
Thank you, Dan, for that explanation. And this highlights what's wrong with example one. Is it one page to the risk? It's either time, capital R time equal to small r times I or small I times X. And this example does not fit into that. I mean, you cannot see that formula in this example. And you just gave the formula one page earlier. So these examples have to be reformatted so that they fit that formula of R times I or R times X. And you cannot ferret out of this without Dan's explanation of how that fits. So that's what I was trying to say in my comments that Dan Stram read, that these examples need to have the variables shown by their name with their units so that you can understand them. Because in their present form, this example, we had to have Dan Strom explain that to the committee. And that's not going to be available to your casual user. So this is really important because this is communication. Thank you.
Thank you. I would also comment that if the EPA is gonna develop examples that demonstrates multiple routes of exposure and multiple scenarios, maybe the committee should provide some guidance whether that implies additivity in risk, additivity in dosimetry. That could open another can of worms and say, well, how do we know all these are additive? But I think the comments are very helpful. Yes, Mayor.
I have just a quick comment. So I think there are some terms in the examples like atmospheric dispersion factor, which are not defined in glossary. I think it would be useful for the readers to have the definitions. Yeah, thank you.
Thank you. Anyone else? It looks like we're ready to move to chart question 4C. Okay, Dr. Coolins.
Okay, question 4C is about the distinction between the two quantities of incidence and morbidity. Can we go to the next slide? So these two terms are treated as being interchangeable in the current draft of FRG 16. They're included one with the other parenthetically. Next slide. Incidence clearly and unmistakably refers to the diagnosis of new cases. Next slide. Morbidity, on the other hand, refers to the existence of disease and may also refer to certain aspects of the disease or its results on the human body. And it has aspects of prevalence and may refer to undiagnosed disease rather than diagnosed disease. Next slide. So our recommendation, we kind of all agreed in our subgroup that that the references to morbidity should just be removed and that the term incidence should be used exclusively for what is meant by incidence, and that if morbidity is going to be used for some other purpose, then it needs to be very clearly defined and distinguished from incidence. And that's what we came up with for our recommendation.
All right, now let's turn to group member.
Hi, good morning. This is Ruth. I just wanted to clarify that morbidity refers to diagnosed disease and not necessarily. So I think there's there was a typo on one of the bullet points in the slides.
Could you put the slide back, the last slide back up?
Sorry, just to clarify, morbidity often refers to symptomatic disease, not asymptomatic screen-detected disease. That's where the distinction comes in. It's a fine point, but just to be crystal clear on this one.
That could be clarified, but I really think that you would be much better off just eliminating morbidity and using the word incidence. And
Absolutely, I completely agree. The word morbidity should be eliminated, and charge question group 4A had the same recommendation.
okay, thank you.
The morbidity could also be described as a totality of diagnosed disease, whatever way it was diagnosed. But it's a disease that's been diagnosed, treated, exists, and so forth, and following up the person until they recover, they could recover or die.
But Ruth reminded me that morbidity could also refer to undiagnosed disease. So, I mean,
Oh, sorry, this is what
you can have a disease without it's being diagnosed and you still have morbidity. Doesn't have to be diagnosed disease.
Morbidity is too late, and no, it has to be diagnosed disease, but it does not have to be symptomatic disease. It has to be disease that is diagnosed without symptoms potentially, and morbidity, as Dr. Savlovsky just pointed out, it's a mix of incidence and prevalence, and that's the real problem because it does not refer to a rate. Incidence refers to a disease rate. Morbidity is a mix of prevalent and incident disease, and therefore is not necessarily a rate. So again, the term morbidity should not be used throughout the document in place of incidence. It's too misleading.
And I completely agree with what Dr. Pfeiffer is saying. One more note is that the minute you start using the word radiogenic or implying that we suspect that these cases were caused by radiation, we're implying incidence. So cannot be, prevalence. It's new cases that we are saying radiogenic. And I also haven't seen in the literature anything about morbidity, radiation associated cases. Plus you're using in these calculations, you're using incidence data, incidence risk estimate. So I'm not sure why jump from incidence to morbidity. There must be some reason, but it's not indicated in the in this report.
I just wanted to note that at least informally, the use of the term morbidity includes something about the severity of the disease that hasn't been mentioned yet. It's certainly, and if something is morbid, or if you have a morbid fear of something, it implies that it's a very severe.
All right, Dan.
Well, Wei Sheng said I could read this, but the NCI website has 4 definitions for morbidity. Here, it's short. Refers to having a disease or a symptom of a disease or to the amount of a disease within a population. Morbidity also refers to medical problems caused by a treatment. So those are 4. So you know, which of those four is EPA intending here? I think I agree with everybody who says that that's not the word to use here, so.
Well, if EPA has any clarification, that'd be great, but otherwise, it's okay. The committee gonna make its recommendation.
Yeah, thank you. I think in the context of FGR 16, we only were looking at incidence of disease. And there are some publications that unfortunately use it interchangeably. And before this, when we looked at this, I reached out to a couple of epidemiologists and asked them. And I got a little bit of conflicting answer. And so that's when we added that to the charge question. So let's ask the panel. And but in FGR 16, when we say morbidity, we really mean incidence. And we have used them interchangeably.
Thank you. Dan?
And another comment, I hope, Tom, that I'm not getting into policy, but I believe that Superfund, it limits risk of cancer incidence, 10 to minus 4 to 10 to minus 6 lifetime risk of cancer incidence. I believe that's in the CERCLA statute.
Thank you. Any further comments? Looks like we're way ahead of schedule.
That's it.
If not, I mean, I'm gonna turn this to Dana, but just a quick housekeeping item. Dr. Strom suggests the panel take a group photo. So if we're not in a hurry to leave for the airport, after the meeting, we can find a place. You're the photographer. You pick up a place, okay, Dan?
Photography is all about light, so we need to find a place where we're well lit and have a probably neutral background.
All right. Dana, it's all yours.
The next item on the agenda is public clarifying comments, and there are no registered public speakers, so that we can move on to the next step, which is next steps
Perfect.
in the review process. So since the panel has finished deliberating on all the charge questions, so now the panel is ready to move on to the writing phase. So the lead discussant now will be the lead authors. So we all know who the lead discussants are. So you know now you are the lead author. And the discussants will have 6 weeks to prepare the written response to charge questions. So that will mean July 12th is a deadline for the lead discussant to submit the written response to charge questions to me. But of course, before you can do that, the associate discussant have to submit their response to the lead discussant, and then the lead discussant will integrate and put the written response together. But since we have already gone through the deliberation in this meeting, so you have pretty much consensus in the written response. So you just have to elaborate on the response some more and write in more detail and put in the references and so on. So, but the lead discussant have to write up all the responses and then circulate to all the team members. The team members will review and edit, and the team must reach consensus again on the written response before the lead discussant can send the written response to me. So this is very important. You know, you have to reach concurrence on the written response. Okay? And then again, the deadline for submitting to me is on July 12th. So after I receive all the written response, I will put together the panel report, the draft panel report, and the panel chair will review and edit. So when we think the report is ready, then I will schedule a follow-up meeting for the panel to deliberate on the draft report. And the report will also be posted on the meeting webpage for the public to comment, and also EPA will comment. So that will be the next step, immediate next step. Of course, there will be other follow-up steps. Could you have heard about it before? So I'm not going to go into all the detail. So right now, the most important thing to remember is the date, July 12th is a due date for sending the written response to me. And then we can move on to the, putting the report together. Okay? Any question?
Then I do have a question that is, do we have a anticipated deadline from between July 12th to the time that we submit to EPA and post on its website?
The immediate deadline is July 12th, and I do not want to put a date yet because we have to see how the report goes.
Okay.
Sometimes, it may need more deliberation, so I don't want to set a deadline. But usually, from the start of the project to completion is 9 months. So that gives you approximate timeline, but I don't want to go into all the detail about, what is the next step, because it really depending on the availability of the panel before I can schedule a date, for the meeting and so on.
So Diana, could you explain how to tier the recommendations? So that's a big part of what they'll be doing when they do the write-ups.
Well, actually, we mentioned it a few times in the recommendation. We usually have categorized the recommendation into 3 tiers. So for tier 1 those are the recommendations that the panel think the EPA should incorporate and make the changes in the document, in the draft document before, it finalized. For tier 2 recommendations, usually suggestions. It'll be nice for EPA to make the changes, but they are not as important as tier 1. Okay, so it's really up to EPA to make the decision, whether they think they can want to make these changes. And for tier 3 for future assessment. So because of the timeline, or because there is really a need for more data, so it's not something that can be changed right away. So that's why we group those into tier 3. That is for future assessment. Usually maybe more research is needed. So is that clear about your tiering of recommendations? I see nodding the head, so I think it's really clear.
Who assigns the tier? Who assigns the tier designation?
The panel. First, you start with the team. The team make the recommendation. Every charge question, you will have some recommendation at the end of the response to charge questions. And then the entire panel will deliberate for all the charge questions. So you start with your team first.
So Steve, if you go ahead.
Oh, I just wanted to add, it's not unusual when a panel comes back, when they have their full draft together and they have their final meeting to finalize the draft report, that a lot of the discussion would be on whether something is tier 1 or tier 2. And, that's kind of what we do in that final deliberation. So you all do it together.
What I'm getting at is this: the individual team assign tiers to their recommendations?
Yes, you start with that. And then when you have the draft report, the entire panel will deliberate on the draft report, and then the entire panel has to agree on it.
So Dr. Simon, when you propose a recommendation, you could say, I think this is tier 1. And if your group agrees, that's great. If they disagree.
Okay.
That's strong.
On the Hanford Advisory Board where I serve, they are very explicit about what consensus means. It means one, I understand it, two, I can live with it, and three, I will support it. I would like to know what EPA means by consensus.
I would generally agree with that definition. Yeah, and we're striving for consensus. It's not an absolute must. But it's more powerful if we can consolidate around one set of recommendations, and often panels do, but it's not an absolute.
So in other words, if I could add, if you have a minority opinion, you disagree, maybe this is 3 dimension, you elaborate. This is something I cannot live with. So just right. It's a possibility, but I agree with Tom that a consensus statement recommendation carries much more weight than.
And occasionally we have a minority opinions expressed in reports, and I do not see that as success or failure. I just see it is what it is. But of course, we're striving for consensus to the extent that we can get it. That's a good thing.
Dr. Wang.
So this question is for Dr. Wang, and if I get it correctly from you, all the editorial changes will be included in the appendix. So it's not on this tier 1 through 3 recommendation. Is that
No.
correct?
No,
Okay.
editorial comments will be put into the appendix of the report.
Thank you.
Lydia?
Thank you. This is also for Dr. Wang. Can you describe the timeline beyond the 6 weeks deadline? How does this process proceed after we submit the comments in 6 weeks?
Okay, after everybody submit their written response to me, I'm the one who will put together the report. And of course, I may have comments and send the comments back to the lead author, to the entire team that you have to address. Okay, sometimes it can be editorial. Sometimes I may think, the response may not be adequate, something like that. So
you will be the one to reconcile, for example, we are right now writing our questions, but how do we reconcile them between them? Is that Dr. Zhu will coordinate
yes,
that?
so if the team cannot agree on certain things, I may arrange a team meeting, like I already suggest team meeting for some of the charge question even before the deliberation. So sometimes it may be necessary to have a team meeting, and then I will organize for the team meeting to have discussion.
And can I add too, we also occasionally rely on our chair to join in, and we lean on our chair to help, break through tough spots if needed.
Thank you.
One question for Dr. Wang, Diana. That is, during writing, if the group has question for EPA, should they contact you, or is that a possibility?
Yes,
Okay.
if the team has some question that require clarification from EPA, you should give me what is your question, and then I will contact EPA for the response. Yes, it is possible. And it occurs quite often.
Hi, I have a follow-up question. This is Ruth Pfeiffer.
Okay.
Is there an example, Dr. Wang, you could send how there is this, do you have like a template or an example of the summary for the charge questions? That's my question number 1. And is there a written summary of what the tiered recommendations are? Is this in writing? Do we have that?
Well, first of all, I can send a sample report to the panel, so you have some idea how to write up your written response. Yeah, so I will do it today. So I can send out the Marson report, which is the most recent one, which Dan Stram was the chair of that panel. So, and some of you were on that panel, so you have a better idea of how the report looks like. So I'm gonna send that out part today, so you will see it before you even go home.
Tom, I wonder if you want to add a few comments or clarification in your opinion from EPA standpoint, what type of recommendation you think would be an example of tier one, right? It had to be maybe,
Yeah.
and we have our perception, but you have your perception.
I guess that tier one, what I would think is a recommendation that you believe needs to be addressed for this document to be successful. Right? Like this change probably should be made. And if you all say so, that's a nice, powerful tier one recommendation.
I can give a very simple one. Could you guys just talk about remove morbidity and use incidents? So, that will be a tier one recommendation, right?
Yeah.
And also to actionable within a short period of time, right?
Yeah.
If you think this is really important, but takes another 10 years, that means this report failed altogether.
Right. Yeah, so that's a great example. We heard a lot of discussion about definitions that need clarity. I think those are tier one type recommendations. As an example.
Any more questions?
Wait, so I don't remember the answer to, so after the July 12th, what happens to the report next?
I am the one who.
So you put it together and then
Yeah.
do you send it back?
As I review it, I may have some questions or I will contact, individual teams.
Okay, thank you.
And then ultimately it's sent back to you and put on public display ahead of your final meeting where you work to finalize the draft.
I think there will be a sign off for the entire panel when we think it's ready to be released, right?
No, not the
way.
entire panel, but
Okay, okay.
individual team, because there will be some back and forth, there may be some discussion between the teams, so that will take some time. That is probably the longest time, is to get the initial response in order.
But so then you're allocating time for the EPA to do these requested changes. How long?
No, that doesn't involve EPA at all. This is just between the team response.
Yeah.
The team has to agree on a written response.
Okay, and then once we agree, then it goes to the EPA to implement these
No,
changes?
not yet.
No.
Then we have to put all the individual response for every charge question into the written report, okay? So, and then the panel chair has to review the entire report. So that also will take some time, okay?
Mhm.
Then when we think it's ready, it will be posted, for the public comment. And also, then the team, the panel will review the entire report. And EPA can review it. That's when all the comments come in.
Yeah, but ultimately, it goes to the chartered SAB and then they'll transmit it to the administrator and to the public. So the panel's work will feed up through the full board of the SAB. Only the full board is allowed to give advice to the administrator. So your work will be put for a final review by the board in a public meeting.
I'm sorry if I'm probably misunderstanding. So for example, if we are requesting the type 1 or level 1 changes,
Yes.
it will take some time to implement them. And if EPA implements that, will the report come back to us for
No.
review?
No.
You
That's
offer
what I've
advice and then it's out of your hands. Yeah, but there's a certain accountability that comes with the SAB report. I mean, this team is a well-qualified team and it's in public view and you're making recommendations. So the agency will have to figure out how to handle your recommendations.
SAB will have a final quality review of the report once we think we're finished. Then it may come back to us, say, our review report needs improvement.
But ultimately, EPA will not bring it back.
Yes, Dr. Simon?
Two short questions. The first is, just clarify this for me, please. Do you want us to include our editorial comments in this report, even if they go beyond the charge question?
Yes. When you submit the written response on July 12, please include all the editorial comments. I will just insert them at the end of the report.
Okay, fine. The second part of the question is, at this point in our report, we no longer need to associate the identity of a group member with a particular comment. It's just the comment of the entire subgroup.
Yes, that's
right?
correct. That's correct.
Okay, fine. That's it. Thank you very much.
Thank you. Any more questions? If not, well, we had a great meeting the last 3 days. So I would like to thank the panel members for their hard work and dedication. I know that a few of you actually attend an international meeting right before this meeting, right? And they came here jet lag, no sleep. And also that also applied to the panel chair. He arrived actually at 5 a.m. on the first day of the meeting. And then we have our meeting start at 9 a.m. So I really appreciate, all the dedication from all the panel members and hard work. And also, the entire panel is actively engaged in the discussion. So I really appreciate that. I will also mention that I know that there are many members of the public, they actually listening online, or they can be watching the live stream. So I would like to thank the public for the participation. I would also like to thank the Office of Radiation and Indoor Air and Oak Ridge team, because they really gave great presentations on the first day, and also answering all the questions from the panel. So I really appreciate that. And last but not least, I would like to thank our panel chair, Dr. Yiling Xu, for his leadership and leading the discussion and the guidance. So this concludes the SAB radionuclide cancer risk coefficient review meeting. And the meeting is now adjourned.
Can I add a comment?
Yes.
First of all, I think I wanna say thank you to Dr. Daniel Wang for outstanding coordination and facilitation of the panel. And I don't want to repeat, but this is one of the most engaging panels that I have participated. So thank you for all your insights scientifically and everything else. It's great. And I look forward to continue working with you to finish this report and help EPA. Of course, I know. Thanks EPA's colleagues, Oak Ridge colleagues. I wonder if Tom, you want to say a few words?
Well, I think it's already been said, but this was obviously Diana did a great job leading the development of who serves on this panel, and it showed this week. And just, keep at it. This is the stage where the meeting's over. It's often you can kind of let your guard down and take a breath. But sometimes right after the meeting is the best time to write up these reports while it's still fresh. So let's just keep the motivation, and thank you all for all your hard work.
I want to say thank you to the tech people. You guys make this meeting.
All right, I have a question. All right, this is you. Yeah. All right, just senior moment. I just lost. Good grief! I'm sorry. I just lost it.
You can read that question after photo.
Yeah. All right.
Microphone, please.
We're talking about taking a group picture.
I'm sorry, we're gonna miss you and Dr. Simon online. Sorry.
Well, we could take them, if we can get their pictures on the screen, we could pose in front of the
Yeah,
screen.
maybe you can.
And then
do this.
everybody would be
yeah,
there.
yeah.
Can we assemble over the screen? Yeah, look at we got three panel members there.
Yeah, along with
Yeah, and even the people online. I think that might be a good background. So we will need a photographer.